Hello guys, in this video we will just talk about proving. So we've discussed all the 7 reasons that two triangles are similar to each other, so let's use them. So in here, we don't know the question yet, but we're just looking at, it's obvious that this smaller triangle has to be similar to the large one, but we gotta prove. So let's first start with the easiest part. I always like to work with opposite angles. We see two intersecting lines here. So we can say that angle F1 is the same as angle F2. Yeah, because opposite angle rule. We write it there. Opposite angle rule. Then we know that GH, it's a line segment, but this line segment is parallel to DE. Therefore, we see a Z angle. And therefore, we can say that angle H has to be the same as angle E because of the Z shape. Think about an armpit method. So we can write down angle E is the same as angle H. And why is that? Z angle, but we use now the word alternate angle. We write that down. We can come to a conclusion that angle F1D has to be, has to be similar to triangle H F2 indeed, and then the last one, D with G. This is, by the way, it's not needed though because this is angle F, but it's not wrong if you write it. Let's go to this one. Yeah, pause the video, do this one yourself. I'll write it down. Make sure that, of course, this is a triangle, so you write Q1 and P here. And we can even conclude that angle T has to be angle S because, of course, it's the last one. If this is 90, if this is the same, then T and S has to be also the same. But we focus on these two, so we can write down triangle PQT is similar to triangle RQS. Let's go on, guys. To the third one, we can see an F shape here. And then we have to, I think, prove that ADE is similar to ACB. So let's do that. So let's work with the F shape. We can see, put some symbols, that D1 has to be the same as C. So that's what we can write down. Angle D1 has to be angle C. Here we also see an F. Yeah, it's like a flipped F. We know that E1, has to be the same as B. So we write down angle E1 has to be the same as angle B. And the reasoning, F angle, but we can write corresponding angle, and we can write down triangle ADE. Triangle is similar to triangle ACB. Then we go to the last one. Here we have a parallelogram and we have two triangles here, two intersecting lines. There's a lot going on in this one. So now we need to pay attention also to the question. We want BF. We want to know this side. So could be that we have more options, but to measure that, we need to indeed figure out enough sides to calculate in our ratio table. So let's try this one. So, nope, here. Let's start. We know from the rules in a parallelogram that this line is parallel to this line. That's something we know. We also know from the rules of a parallelogram, if this is 3, then this also has to be 3. what else do we know? We can see opposite angles, so we can also see that this one is the same as that one. And because of the parallel lines, using what we know for the parallelogram, excuse me, we also know that angle E has to be the same as angle C. So we can write down angle F here is the same as angle F, opposite angles, and angle E is the same as angle C because of the alternate angle. Therefore, triangle AEF is similar to triangle BCF. And you can make your ratio table and start calculating. So I really hope these 3 videos help with proving. Of course, the calculation work you still need to do. You can try it using these exercises. I will zoom out a little bit so you can maybe grab the measurements or just work in your book. But you can definitely calculate now because you have done the proving, which is a very, very important step.